All right, in this video, just wanted to spend more time just going through these last part of the notes and how you solve these equations. This is the most important concept from these notes. This is the most common style of test question that you need to know for these part of the notes, and they're very commonly missed. I would say most students will not get full points or full credit on these style of questions on the test because they just miss little parts of it. So they get some of it right, but not all of it. So again, I want you to look at this first question. I'm just going to spend time going through these three problems. I'm glad you're watching. Again, on the first one thing you never want to do when you're solving an equation is get rid of your variables. So that's why on this one we are solving by factoring. You don't divide this over and get rid of it. If you get rid of your variables, you're getting rid of answers. So you never want to do that. So instead, we solve this by factoring. We factored out the common factor of cosine of x. And now just the way you would solve any factoring problem is you now set each factor equal to 0 and solve it. And so if I set the cosine of x equal to 0, I'm going to get one scenario that I'm going to need to solve. And then I'm going to set this equal to 0 to get my other part of my answers. And so let's just start with the cosine of x equaling 0. So look at your unit circle and we would say, okay, where do I have x values that are at 0? Or you would say, which angles give me a result of 0? Remember that cosine values are the x-coordinate values. So we're saying, where would I have on the unit circle, where would I have x-coordinates that are 0? Well, x-coordinates that are 0 just mean you're going right 0. So I can go right 0 and go up to pi over 2, and that's going to give me one answer. Which you could leave as just pi over 2, unless the problem specifically wants rounded to 3 sig figs, and then we would just hit pi divided by 2 in your calculator. But I can go right 0 and go up. I can also go right 0 and go down, and so I'm going to get my other answer for that problem right here at 3 pi over 2. And so that's why, because it says specifically from 0 to 2 pi, that's one full circle from 0 to 2 pi. So I got to list all possible answers, which these notes did not. So that was my first answer, was pi over 2. My second answer would be right here at 3 pi over 2. And that just takes care of this part of my answer. The last part of my answer, if I solve the second factor, I'm saying, okay, where would I get angles that give me a result of -1? And so I'm now looking at where are my x-coordinates equal to -1. Well, within a unit circle, -1 means I'm going left 1 and up nothing. So if I go left 1, and I can only do that in one location here, if I go left 1, I'm now at pi, and that's giving me my third answer. And so this one should have come with 3 answers, and that's where you would have found them. And again, you can leave them in exact form or 3 sig figs unless the directions say otherwise. And that's what your IB test directions are going to say. It's going to say leave all answers in exact form or rounded to 3 sig figs unless the directions say otherwise. But again, notice that this one was done in terms of radians because of what I'm given right here. And so I gave my answer in radians. Second question. And again, I first want to just solve everything I can algebraically first. So we would start by subtracting 1 to get 4, divide by 9, and then now when you have the sine squared of x, that is the exact same thing as saying the sine of x, the entire function sine of x squared. And that's what allows us to just square root both sides and get this look here. Really important that you recognize this has a positive and a negative, because that gives us double the answers. And so we have more solutions. A lot of times students will leave out the plus or minus, and they're going to miss out on half the points for this because they're only going to get half the answers. You got to do the plus or minus when you take the square root of both sides. So let's just start by looking at the positive solutions first. So if I do my inverse sine of positive 2/3, I'm going to get my 0.730. So let's take a look at what that would mean. So I first have, remember this is 3.14. I'm sorry, this is 3.14 divided by 2. It gives you right here. This is about 3.14 and so on and so on. And so keep that in mind in terms of working with radians. So if I have 0.730, right, that's somewhere in this area right here. remember this is a sine function. Sine functions go up and down. They are y coordinates. And so I am, for my first answer, going up right here to get that first answer. So this angle is the 0.730, and I went straight up, and I'm getting this answer. And so that's the first solution that we're listing on this, is right there. And again, that's just based on going in the upward positive direction. Remember, we're just doing the positives first. So keep this in mind. If I went up to get that answer, and I'm thinking up and down because this is a sine function, well, where else could I go up and get the same answer? So if I go over to the other side of the circle, and I go the same amount up, positive y up, I'm going to get my next solution. And so this reference angle would also be 0.730, since this is 0.730. And so in terms of our answer, well, right here I'm now at pi. So if I do pi minus 0.730, I get my other positive solution right there. And those are the first two answers that you see listed. Well, we also had a minus sign. And so now we get to deal with the negative y direction. So now I'm going to be going down to get my other two answers because it's negative 2/3. So again, my reference angle doesn't change. This was 0.730, so this is 0.730. But now I'm looking in terms of going down because of the negative. So I'm going to travel downward some amount to get this answer. So right here, consider this to be at 2 pi. So if I did 2 pi minus 0.730, I'm going to get this answer. Well, where else can we go downward direction from the x-axis and get the same answer? Right here, I'm going to also go down the same amount to get my next answer. So again, the reference angle doesn't change. So right here we were at pi. So now I'm going to do pi plus 0.730 to get this solution. And so that's where all four of those solutions are coming from. And again, it's really important that you pay attention to finding all of your answers. There were 4 answers you could find here. And again, oftentimes students are only going to get some of those and not all of them because they're not thinking fully on this statement right here, that I have to find everything from 0 to 2 pi. Also considering the plus or the minus. So I got 2 of these answers because of the plus. This is my positive y here. This is another positive y here. So that gave me the positive 2/3 answers. But because of the negative 2/3, I also had to travel downward to get this answer and downward to get this answer. And those are my other 2 solutions. And those are the 2 that you see listed as the second 2 solutions. All right, last one on this. I spent a little more time on this one because we didn't in the first video, but that's why I'm making this video. So right here, again, I'm now working with a cosine function. So a couple things here. I am working from left to right, and because it's cosine are x values, so I'm working left to right, and I'm only now listing answers from 0 to pi. So it has to be greater than 0, has to be less than or equal to 3.14 in order for it to count. And so that's what we're looking at for this domain, for this particular problem. So a couple things. First is I would first divide by 5. And now we're saying, okay, the cosine of what angle is equal to 3 divided by 5, or 0.6. Notice that because this is an interior function right here, we deal with the 2x last. And that's really important that you don't divide things by 2 until the very end of the problem. That's going to be your last step that you would take. And so here we are right here after dividing by 5. And now we're going to say, okay, the cosine of what angle is equal to 0.6. And so if we do the inverse cosine of 0.6, we get the angle of 0.927. So remember, cosine values work left and right. And so if I have my 0.927 right here as my reference angle, is my main angle, the 0.927. And we have this first, that gives us our first answer that we have right here. Well, where else would I have that same value? So keep in mind that this is positive. Because I went right, right? X's cosine values are x values, they go right and left. Well, if I have a positive x value here, where else would I get a positive x value, right? Where it means I'm traveling to the right because it's a positive x value. So this length that I have right here can be mimicked down here. So I'm also traveling to the right because it's a positive x value to get my next answer. And so we'd say, okay, well, where did that come from? Right? It's same reference angle of 0.927. So now if I did 2 pi minus 0.927, I get my next solution right here. And again, I traveled right and left because it's a cosine function. So 2 pi minus 0.927 gave me this answer. And some people might look at this and say, oh, wait a minute, I can't use this because it's not within this domain. It's not less than 3.14. Well, hang on, we're not done yet. So the very last step is to now set all of my answers, this guy and this guy, equal to 2x, my interior function, and solve for x. Now when I divide them by 2, I get this answer and this answer, which are both between 0 and 3.14, and so those are the two answers we're going to keep. One thing to consider on the test, because again, here's a really commonly missed problem, is to do as much as you can do and come up with all the possible solutions first, then set them equal to your interior function and solve for x, then just keep the ones that are within the domain. So go beyond this first and list all these possible solutions you can come up with, then set them equal to your interior function to solve for x. Once you're done solving for x, then you would only keep the solutions that are within the given domain, and in this case it was from 0 to pi, or about 3.14. And so that's why we kept those two solutions. So really important. I hope you're hearing me stress the importance of, in a test scenario, finding all possible solutions within the given domain. That's really important for solving trig equations.